Okay, guys, let's get started. You can pick up your problem sets afterwards. So today we're going to start talking about market power. And we'll start with the most fundamental idea with market power, which is a monopoly. So we'll talk about what a monopoly is and why does it arise. Natural versus unnatural monopolies. We'll then talk about monopoly pricing, optimal pricing by monopolists, how they want to reduce quantities below what's socially efficient. We'll talk about Lerner's markup rule for determining optimal prices. We'll talk about ironing in a monopoly optimization, and we'll do an application to pricing on eBay. We'll then talk about the monopoly distortion and incidence under monopoly, and we'll contrast this to incidence under competition and talk about how it relates to demand curvature, as well as applications of the logic of incidence, as we talked about when we did perfect competition, and we'll do applications to foreign trade, taxing foreign trade, and creating new markets. Okay, so when you hear the term monopoly, it sounds like this is the only company, right? But in reality, the basic mechanism in monopoly that you want to try to move prices in the direction that's valuable to you applies to any individual who's not a perfect price taker. And the real question is how severe that effect is, and that depends on the size of the distortion. So the real distinction between monopoly models versus oligopoly models is that monopoly models focus directly on the effects of intervention through that individual firm rather than through other firms in the industry. Second, monopoly ignores welfare effects that happen through the impact on what other firms are doing. So the value to other firms is viewed as either completely ignored or it's viewed as being pecuniary. And therefore it can't be used to think about cross-firm externalities as we talked about in the externality lecture. And finally, monopoly models can't be used to study changes in the structure of the industry because they only feature a single firm. So they focus on the incentive of one firm, and this is sort of an input to other analyses. Okay, so let's try to think now about what causes firms to have market power in the first place. There are basically two types of firms with market power, ones that have natural monopoly or ones that have unnatural monopoly. So some examples of unnatural monopoly come from barriers to entry that we talked about before that are imposed from outside. So intellectual property, either private trade secrets or government protection, which will be the focus, I don't think of this next Tuesday's lecture. I think it's going to be a week from then. But second, lobbying and protection. So these can be very harmful from both a static and a dynamic perspective. And the usual way that monopoly is addressed in this context is to try to put restrictions on or stop lobbying that could create these sorts of monopolies. Private or illegal violence is another source that we discussed earlier. So mafias gain a monopoly through intimidating their rivals. Like in gambling and other sin industries, and usually we try to deal with this monopoly problem through law enforcement. And finally, there can be advantages from being a first mover or having talent or being first to the market that can keep others from competing. And in principle, this could resolve itself in time, but it doesn't always for the reasons that we discussed in class before. Sometimes people just have such talent that it's not easy to catch up with them. But to the extent that you can address this, you do so by transparency or lowering bureaucracy, etc. Okay. Things are trickier when monopoly is inevitable or natural. And Zefeng, what's the definition or an example? What's the definition of a monopoly being natural?
Yeah, I think it says, from what I understand, is that when you have a monopoly that is even more efficient, then you have a lot of competitive firms. For example, like the electricity firm, or something like the company that builds the highway system.
Yeah.
this kind of stuff, when you have one firm, it's more efficient than having a lot of firms.
Yeah, so the most classic example is when there's economies of scale through the full range of production, so that it's always more efficient to have as large firms as possible. But you don't necessarily need this. You can also have a natural monopoly if you have what's called sub-additivity, which means that even though costs might be increasing beyond some point, it's always the case that it's more efficient to have one firm than to break it into two firms. So the crucial issue is whether there's economies of scale over the relevant range up to the equilibrium price. So is Orlando here? No? Does someone else want to give some examples of natural monopolies? Yeah, Moonsu.
Maybe railroad?
Yeah, because it doesn't often make sense to have two railroads going along the same route, because you can use that railroad track quite intensively, and it would be a waste to do other railroads. Electric utilities, as Zafang mentioned, are another good example. Social networks or telephone networks, if there's no ability to interconnect between networks, are another natural example, because you want everyone to be able to reach everybody else. Another thing that has natural economies of scale is monitoring people's income. Because if I monitor the income of one individual, it's much easier to monitor the income of all the people that he's connected to, because I can sort of trace the money through the system. And that's one natural reason why taxing is centralized in the central government rather than being farmed out to various private companies to each monitor different individuals' incomes. Yeah, Franklin.
What about something like Microsoft, where people use it because everyone else is using it?
Well, so that's sort of like social or telephone networks, yeah. Public transportation in many settings, like the railroad, is a good example as well. Donnie, did you have a question?
Is violence a natural monopoly? Like having a government police force or something like that, so you don't have competing violent services?
Yeah, I mean, probably. I think that that's very similar to monitoring income. I also think another reason why it's natural to have a monopoly on violence, which I think is actually not well reflected in economics models, and I was talking to someone about this recently, has to do with reputation. So I think what's really crucial to violence is reputation. You need a reputation for enforcing things correctly.
Being willing to?
But yeah, and the problem is that in order to have such a reputation, you need to crack down on people, sometimes even if they haven't done something wrong, just so you have the credibility that you'll always crack down. And so that requires some amount of waste. But if you have everybody doing that, then everyone's trying to acquire such a reputation, which creates more and more waste, and then there's a lot of excess violence. Whereas if you only have the government, then only government has to be occasionally tyrannical in order to keep its people in check. Whereas if everyone in society is being occasionally tyrannical to keep other people in check, you get chaos. So I think that's probably one of the reasons why it really has to do with these reputational effects. Okay, so the basic idea is that monopolies reduce quantities in order to try to raise prices, because in order to sell more units, they have to lower the price. And they have to lower that not just on the last unit that they sell, which is necessary, but on all the inframarginal units as well. So that creates a trade-off between them selling more and charging a higher price. So to see this, note that the monopolist profits are price, which depends on quantity. Before we just had price being taken as exogenous, but now we're going to have price depending on quantity times quantity minus cost, which depends on quantity. So then you're not going to want to set price equal to marginal cost. Instead, you'll set marginal revenue equal to marginal cost. And is John Fallon here? Yeah, John. What's the formula for marginal revenue?
It would be the price times the quantity minus the quantity times the cost. No, I'm wrong. Sorry, that's not marginal.
The marginal revenue, yeah.
So it would be wouldn't it be the marginal, or the price times, just the price minus the marginal costs?
No, so the derivative of the revenue. Revenue is P of Q times Q. What would that be?
P of Q Q plus P of Q times Q.
P prime of Q times Q, right? Yeah. Okay, and so that gives us two components in marginal revenue. One is the price, which is what we want it to be, right? Because then you would set price equal to marginal cost. But then there's this extra market power term, or Cournot distortion, which lowers the marginal revenue below the price and is proportional to how much the price falls when the quantity increases multiplied by the quantity that you have. So the distortion is proportional to the number of units you sell. If you're big in the market, then you have a big distortion. In the amount by which you move price, which is, if you're a small part of an industry, then changing your quantity won't move price by much, right? So distortion in both of these ways is proportional to how big you are in an industry, and a classic way to express this is the elasticity of demand for your product. But let me just start by showing you some examples of marginal revenue curves for different demand functions. So up here is a linear demand curve, and that's in blue, and then in purple is your marginal revenue curve, and you'll notice that it slopes downward, and it is twice as steep as the demand curve, so it diverges more and more as quantity increases. Over here is a exponential demand curve, and that has marginal revenue that's exactly parallel to the demand curve, and so they have the same distance between them at every point. Here is and that's convex demand, so that leads to the marginal revenue curve being closer as you get increasing quantity as compared to this linear demand curve. Now if we go to a concave demand curve, you see these things diverge even more quickly. On the other hand, if you go to a very convex demand curve, this is a constant elasticity curve, they get further, which one's constant elasticity? I think this is an exponential, and they're constant distance apart. Here, this is constant elasticity, and they're actually getting closer together as the quantity increases. Now, the way that you find the optimal price is you just set the marginal cost equal to the marginal revenue. Let's say the marginal cost corresponds to the x-axis in all these cases. Then you find its intersection with the marginal revenue. You draw a line up from that to the demand curve and over to find the optimal price. Okay. So let's write the marginal revenue another way. Let's say that it's P times 1 minus 1 over the elasticity of demand. Is Luke Jane here? Luke, you are. I saw Luke earlier. No, I know. I'm looking for Luke. He was just here complaining about his problem set. Okay. Anybody else want to try to derive this formula? Yes, Sang.
So we have elasticity is negative Q over Q times dP.
Yep.
So we change we have the P prime, the original formula. So
Yep.
that's dP dQ. So
Yep.
we plug in the dP dQ from elasticity.
Exactly.
To the formula.
Yep.
And we get that.
Yeah. So just to go through that slightly more slowly, elasticity equals negative dq dp times p over q. And so negative 1 over the elasticity is equal to dp dq over times q over p. And so that gives us that p over the elasticity is equal to p prime q, which is the marginal revenue minus price. So one thing this tells us is that marginal revenue is always negative if the elasticity is below 1, that is, if the demand is inelastic. And therefore, the elasticity of demand determines the level of prices. It summarizes how large a firm is in the market, in some sense, how much substitution there is to other goods. And if you rearrange this formula, it yields the canonical formula that the relative markup, price minus marginal cost divided by price, is equal to the inverse of the elasticity of demand. Now this formulation can be problematic if we have a price that's negative, which can occur in some markets. So sometimes, for example, you get subsidized to adopt a technology, like to use some product, on a trial basis, and there's no way to really define the elasticity of demand if you have that negative price. So sometimes, so for example, in your credit card, you get points for using your card. What's the elasticity of your demand for your credit card? Well, you get a negative price, so it's all messed up. So in that case, it often makes sense to express things in terms of the absolute markup, price minus cost, which is equal to the ratio of price to the elasticity, which was that original Cournot distortion thing we were talking about before, which is also called the marginal surplus in some places. Okay. So this is a sort of simple story, but it has several wrinkles. So imagine that you don't know exactly what demand is. We've assumed that there's like a simple price-quantity relationship, but when demand is uncertain, you have to choose both price and quantity, right? Because you don't know exactly what the quantity will be if you charge a given price, or what price will clear the market if you choose a given quantity, right? There's still a learner rule that you can use, though, based on cost and elasticity, because the relevant thing is then the average quantity that you sell, not the average quantity that you produce. And you can think of the average quantity that you sell as a function of how much you produce, because you'll be selling that in some states you'll just have extra stock. You can also have a case where you learn about demand, right? So if you want to avoid not knowing about demand, you might want to learn about it over time by trying to charge different prices and seeing what people value, how much demand you get. And in fact, you can do an even cleverer version of this. So that's learning from past experience, but Elie Segal proposed a mechanism where you learn from current experience. So what happens is you go to all of the customers and you say to them, what are you willing to pay for this good? I'm going to come up with a price that's the monopoly optimal price against what everybody else says they're willing to pay. And if you're above that, I'll sell it to you at that price. And if you're below that, I won't sell it to you, right? Turns out that that is incentive compatible, right? Because the price that they pay is determined by what everybody else says. And so you can actually learn from the current demand, not just the past demand.
Do you need like a large number of people? A large number of people?
Well, you'll learn best if there's a large number of people, but in principle you don't need a large number of people. You could just learn Bayesianly based on what everybody else says.
But if we are to like the elasticity of the demand curve, it depends on my price relative to the other guy's price.
No, so I mean,
That's a silly example.
if you just have two people, you can still learn something from the other guy's reported price. You just can't learn very much. You can update like a Bayesian on what you think the demand is, and then you can charge the optimal monopoly price against the demand curve that you update to. That's sort of the idea. Okay, so one place where learning is particularly easy is on the internet, right? And this was analyzed in a paper that I had you guys read by Einov et al. They collected data from seller experiments on eBay, where there are many identical items that are for sale at different prices. So on eBay, you can have like the exact same item, sometimes even by the exact same seller, selling at different prices at different times, or sometimes even at the same time. And what they try to do is figure out how changing the price or other terms of service affects the chance that it gets sold, which is effectively the demand curve faced by the people, right? So to do this, they construct an auction version of a demand curve. And Albert, what was that? How did they construct that?
They track like this similar like a seller posting similar similar posting items.
Yeah.
And they see how much they manage to sell. Like the seller they set different they sell different like minimum price.
Yes.
And they check out what happened.
Yeah, that's right. So if you change the minimum price, right, there's some chance that doesn't matter because both of the two highest bids are above that, right? But there's some chance that all the bids are below that, in which case you don't sell it. So it reduces the chance that you sell it. And there's some chance that the highest bid is above it, but the second highest bid is below it, in which case it raises your price. So you can trace out what happens to your average selling price and the probability of sale as a function of changing this minimum price. And that locus that's traced out by that is effectively a demand curve. You can like choose your average price and your average quantity, and you have a trade-off between those, right? So that's just like a demand curve. And it turned out, interestingly, that the basic shape of this demand curve, even though its level was very different across products, its basic shape was very consistent across products. So here's what it looked like. So this shows the expected sales price as a function, divided by the reported value of the object as a function of the probability with which they sold the things as traced out by changing the reserve price. And you see this nice negative relationship. But one thing you'll notice is that these are very, very, very convex, right? They're like sort of nice up here, and then they get really, really, really flat down here. And that, if you fit a third-degree polynomial through this, it sort of looks like this. And that you can use to create a marginal revenue curve, which looks like this. And you'll notice the marginal revenue curve is not monotone, right? So in order to determine the optimal price to charge, you're fine if if your cost is down here. You're fine if your cost is up here. But what if your cost is in here where there are two intersections? What do? Well, you apply the same ironing technique that we did before, right? What you do is you say, we did ironing before, didn't we? No, maybe not. Okay, so let's think about this. Imagine that your marginal cost is in here. Does anyone want to guess which of these points would be your optimum? Right, there's three intersections. Which one would be your optimum? Yeah, Jose.
Well, I think I read in the paper some explanation of being convex. They have a convex revenue, so the points in the extremes are better than the intermediate point.
Yeah.
The logic is that low price may have a low reservation price may have a cascade snowball effect with the bids, and the high price reduces the dispersion.
Well, so I think the explanation for why it's so convex is that basically there's two types of people in this market. One type of people are basically just going to buy the object at a low price and resell it again later. And the other type are people who are actually going to take it home. And so that leads to this like very flat floor. Like if you sell it below a certain amount, it's just going to go to somebody, right? Whereas if you sell it up here, which requires selling it with much lower probability, someone will keep it permanently but pay a higher price for it. But the question is, if your marginal cost were here, which would be the optimal point? Yeah, Lancelot.
I think it would be the third one.
Yeah.
Because it looks like the area of the, I don't know what's that shape, like the half circle or whatever.
Yeah, exactly.
There is greater than the second one.
Exactly. So the area below this marginal cost and above this marginal cost and below the line is smaller than the area above the marginal cost and below the curve, right? Yeah. And that means that there's more profits to be gained going over to this point than there is to be lost by going through this area. On the other hand, if your marginal cost were up here, then the amount of losses you would take from going over to here would be greater than the amount of gains you'd get by going over to there. So if you're above this line called the ironing line, you always want to go to this point. If you're below this line, you want to go to this point. If you're above this line, you want to go to this point. What is the ironing line? It's the area where the area below this line and above the curve is equal to the area above the line and below the curve. And you can always replace the marginal revenue curve with this iron marginal revenue and just forget about the rest and pretend as if you just had a marginal revenue that was like that. That will always give you the optimal thing. Okay. However, marginal revenue curves are generally not decreasing and so you have, so you have to use this ironing procedure. More formally, is that you replace the marginal revenue curve with this ironed version that is always decreasing, and then you can just do the standard thing of finding the intersection. And in fact, this is a much broader procedure. Anytime concavity or stability fails, there's usually an ironed version of the relevant curves that can replace the original one, and you can just work with those. Okay. So monopoly raises prices above costs, and this has two social welfare effects. One is it transfers wealth from the consumers to the monopolist, and while this is a distributive problem, it's not a net social loss. On the other hand, the reduction in quantities caused is a net social loss, because there's some individuals who would have been willing to buy the good at cost who are not now able to buy it because the price is higher. And this is called the deadweight loss from monopoly. And the reason it occurs is the monopolist raises prices on all the inframarginal units. And that also forces the marginal people to pay a higher price. Now, if they were able to price discriminate, to charge lower prices to the people who are on the margin, there would be much less of a distortion. And this elevated price means that consumers create an externality on firm profits whenever they buy the good, right? Because the firm earns an additional markup that's, gives them some rent, which is not mediated through the price system every time the consumer buys it. Now, one way to internalize this could be to give a Pigouvian subsidy to the industry. Another way would be to mandate higher quantities, and we'll talk about that on Tuesday. But more generally, anything that makes consumers value the good more is going to be beneficial. So for example, creating deceptive advertising is actually a social benefit if it convinces consumers to think the product is worth more than it really is. Because the consumers are not buying a sufficient amount of the good, and so getting them to buy a sufficient amount would be socially beneficial. So while it sounds bad that firms would create deceptive advertising, in a certain sense this is actually beneficial because the consumers have a positive externality on the firm when they buy more of the product. So if you can trick them into doing it, that's a good thing. Okay, so to measure these losses, we consider the standard deadweight loss triangle. Like the distortion, it's very similar to a distortion from a tax, except now the level of this distortion is determined by the monopoly's optimization, and therefore has a particular relationship to monopoly profits and other things that we'll explore in a minute. Now there's two different expressions that you can give for this deadweight loss, as usual. There's either the area between the two quantities integrated between the price and the marginal cost, or there's the area vertically integrated between the marginal cost and the price between the let me just draw this. So if you have a demand curve and a marginal revenue curve and a marginal cost curve here, the monopoly produces here, social optimum is here, so the deadweight loss is this area, which we can either add up between these quantities, the difference between these two curves, or we can add it up vertically between these 2 points of either the supply or the demand curve. Okay, so similarly, for profits, this can be measured either, so the profits that the firm earns, they charge that price, is either the square that is price above the marginal cost, so you can take this area in here Or you can take the area between the marginal revenue and the marginal cost curves, which is the area in here. And consumer surplus you can measure either as the area above price and below the demand up here, or it's the area between the demand and the marginal revenue curve up to this point. Those two things are equal to each other, and the reason is that anything that's social value that's not captured by the firm is captured by the consumers. Okay. So this makes the incidence of monopoly fundamentally different than the incidence of taxes under competition, because under competition, the first unit of a tax we put on had no social welfare loss. It just transferred money to the government. Whereas under monopoly, there will be a loss on the first unit. And that's one of several fundamental differences between monopoly and competition in terms of incidence. So physical and economic incidence are still independent. That is, the price that the consumers face is independent of whether the consumers pay the tax or the producers pay the tax. And we'll still refer to the pass-through rate rho as being, if I put 1 unit tax on the firm, how much gets passed on to consumers. But now the tax is not just split, there's an excess burden associated with that tax. So the firm chooses its quantity to maximize profits. And so what, Moonsu, is if I put a tax on this firm, what is going to be the amount of value that the firm loses in terms of profits? Okay, so I want to figure out if I raise the tax by a little bit on the firm, how much profits do they lose? And remember that the firm chooses its quantity to maximize its profits. There's an even simpler way to do it. You could try doing it that way, but it'll take you forever. The firm optimizes its profits by choosing Q. Anybody else? Yeah. So how can you use that, Tiago?
Just make a derivative of the profits with respect to T.
Yeah.
And it will be minus Q.
Exactly. It's just proportional to the quantity. Because the firm chooses its quantity to maximize its revenue, you can ignore all effects that come through the change in quantity, right? And so you can just take the direct effect of the change in tax, which is negative Q, right? So that means that the firm bears the full burden of the tax. It's not split with the consumers. But then, in addition to that, there's an excess burden that falls on the consumers, which is proportional to the rate at which it gets passed through to them, because they're still behaving competitively. And therefore, the change in price is exactly equal to the loss that they take multiplied by the quantity, right? So that means that the ratio of how much the consumers lose to how much the firm loses is equal to the pass-through rate divided by 1, which is equal to just the pass-through rate, right? And again, you can integrate this up as before to say that the ratio of consumer to producer surplus is equal to the average value of the pass-through rate. Okay, so just to see how that works, imagine that we increase a tax on the firm by 1 unit. That'll cause the firm to move its quantity from here to here, right? But how much profit does it cause the firm to lose? Well, remember, the profit is the area between marginal revenue and marginal cost. And basically, when you move this up, that area shrinks by the height of the tax multiplied by the width of the quantity. Now there's this little extra triangle, but that's second order, right? And so the profit lost is really, to the first order, just equal to the quantity. Okay, now when we integrate things up, of course we need to weight by the quantity at each point, just as we did before. Now a tax moves consumer surplus and producer surplus both down, but it raises deadweight loss. Let's try to think, so we use that as a way to get a ratio of consumer to producer surplus, right? Because as we raise the tax up, both the consumer and producer surplus disappear. So by lowering the tax back down, we can get a ratio of the consumer to producer surplus. Now let's try to think about something that moves the deadweight loss down and producer surplus down, so we can get a ratio of deadweight loss to producer surplus. John, what might that be? What's something that would move both deadweight loss and producer surplus down? Some intervention in the market.
One cap and trade. No, just like
Something a little bit like that. Some change to the quantity. What?
yeah. Like we just set the volume like rent control or something.
Well, one thing you could do is you could have the government at cost just produce some of the good, right? So that would move producer surplus down, because now they'd face this competition, and it would reduce deadweight loss as well, right? And this allows us to measure the relative size of deadweight loss and producer surplus. So let's focus on the case when you have constant marginal cost. And suppose another firm comes in to compete, and they produce some quantity Q tilde. And then the total quantity is Q. So then the profits that the firm will make are just the price times Q minus Q tilde minus, this should be the cost. It should really mean price minus cost times this. Sorry about that. Then the first order condition for the firm is going to be price plus P prime times Q minus Q tilde equals the marginal cost. And that implies, right, we could just move P prime times Q tilde to the other side of this equation, that increasing Q tilde is the same as reducing the tax. It's like having a negative tax in an amount P prime, right? And so the change in the price with response to a change in Q tilde is equal to P prime times rho. But that's the same as changing the quantity by 1 over P prime times this. And therefore the amount that the total quantity in the industry will increase when Q tilde increases is equal to rho. Now again, by the envelope theorem, right, the firm chose its quantity to maximize its prices, so profit. So we can just take this exogenous quantity as directly changing and hold fixed the total quantity supplied to the industry. And that gives us that the loss that the firm takes in response to that is equal to negative of the markup that they have. Right? On the other hand, how much does deadweight loss fall by? Well, the marginal deadweight loss from an additional quantity is equal to the markup, right? That's the wedge between how much the good is valued and how much it costs to produce. So that's the social cost of reducing the quantity. And so if we increase this exogenous quantity, that's going to increase the quantity that's actually supplied by the pass-through rate, multiplied by then the social value of that additional unit. So the deadweight loss falls by negative rho times the markup. So we can define the social incidence as when we increase this exogenous quantity, how much does deadweight loss fall relative to how much does producer surplus fall? And that's equal to the pass-through rate again. And then we can integrate this up again to get the ratio of deadweight loss to producer surplus is the markup weighted average pass-through. We have to weight by markup because that's the thing that's multiplying it in these. Okay. So under monopoly, the logic of incidence really differs in two ways. First of all, the the marginal revenue, not the demand, is going to determine what price you want to charge, right? And so that's going to mean that the curvature of demand is going to affect the pass-through rate as well, and we'll talk about that in just a minute. The second way is what we just talked about, which is that there's dead weight loss associated with changing the tax, not just at raising of revenue. So let me now consider pass-through, given that we just talked about the dead weight loss issue. So let's let the price that a monopolist wants to charge comes from setting marginal revenue equal to marginal cost, which now includes the tax, right? So if we implicitly differentiate this, just as we did before to figure out what pass-through was, that gives us that the derivative of marginal revenue times dq dt is equal to the derivative of marginal cost times dq dt plus 1. So rearranging that, we get that dq dt is equal to mr prime minus mc prime, or that the pass-through rate is equal to how much the quantity changes times how much price changes with quantity. So that is p prime over mr prime minus mc prime. Now remember that mr is equal to p plus q prime, p prime times q. So if we then call the Cournot distortion p prime times q, negative p prime times q, the marginal surplus, because if we increase the quantity in the market, that's how much surplus consumers get, because it's the difference between the price, which is the total marginal value, and the marginal revenue. We can then identify the marginal cost curve with the supply curve, and we get that MC prime is equal to the ratio of price to quantity times the elasticity of supply. And of course, P prime, that's just the demand curve, is equal to negative P over Q times the elasticity of demand. So we can then rewrite this whole thing as this. So we rewrite the top in terms of the elasticity of demand. We rewrite the bottom in terms of the slope of the marginal surplus, the slope of demand, and the slope of supply. And we get this relatively simple formula for the pass-through rate, which is 1 over 1 plus the elasticity of demand minus 1 divided by the elasticity of supply, plus 1 over the elasticity of the marginal surplus, right? So there's really two changes that have occurred relative to the case when we have perfect competition. One is that there's this extra minus 1 here, but basically qualitatively this is the same formula we had before. We had the elasticity of demand over elasticity of supply. The really new feature is this 1 over the elasticity of the marginal surplus function. So, Arvid, how do we interpret that elasticity of the marginal surplus? What is that? What property of the system is that related to?
My guesses would be that it's connected to the curvature of the functions.
Yeah. And we saw that earlier, right? Because we saw that that marginal surplus, the area between the demand and the marginal revenue, could either shrink or grow depending on the curvature of the demand, right? And in particular, this thing is greater than 1 for concave demand functions. It's equal to 1 for linear demand. It's equal to 0 when you have a log linear demand, that is negative exponential. And if you have log convex demand, then this makes this negative. And if it's negative enough, then the pass-through rate can actually be infinite. How does that happen? Well, remember when demand was really, really convex, we actually got the marginal revenue was going up, and that forced us to iron, which would have led to a jump in the price from a small change in marginal cost. So let's go back to that diagram. So if marginal cost were to rise from just below here to just above here, the price would jump from here to all the way up there, right? And so if you have convex enough demand, then you can have a discontinuous increase in price from a tiny change in marginal cost. Okay. So in addition to elasticities, we now care about the curvature of demand. Yebin was here, wasn't she? I think she just left. Does anyone else want to give us some intuition about how we can think about demand curvature? Well, one way to think of it is as how much valuation is out in the tails. If you think of inelasticity of demand as really being some measure of variance, like how variable people's values are, curvature of demand is something like the kurtosis of demand, right? So in particular, the fatter tails are, the more curvature you're going to have. For any fat tail distribution, 1 over the elasticity of marginal surplus is going to be very negative. In particular, the value alpha, that parameter alpha that we talked about before, is going to be equal to negative the elasticity of the marginal surplus. So if alpha is small, that's going to make 1 over elasticity of marginal surplus very negative, right, when we talked about Pareto tails. So that means that if it's really income that is generating the variation in demand, then for luxury goods where there's going to be a real spread out in the tails of how much people value it, you're going to expect to have a very large pass-through. And products with very niche appeal, so that there's going to be a very long tail to its valuation, you're going to expect to have very large pass-through, because that makes this 1 over the elasticity of marginal surplus very negative, and therefore makes this whole thing large. On the other hand, things that are sort of utilitarian and that people have very similar values for are going to have low curvature, and therefore are going to have low pass-through rates. Okay, so let me give you just some graphical depictions of this. So let's take again that concave demand curve we had from before. Here the marginal revenue curve is the demand curve is concave, and therefore the marginal revenue curve is moving rapidly away from the demand curve. Therefore, a small increase in marginal cost doesn't lead you to move as much up the demand curve as it does lead you to move up the marginal revenue curve, right? And therefore, the increase in price is very small for that increase in marginal cost. On the other hand, if we have this constant elasticity one, where the marginal revenue curve is actually getting closer to the demand curve as time goes on, a small increase in marginal cost will lead you to move much further up the demand curve than it does up the marginal revenue curve, and so you'll increase price by twice as much as marginal cost increases, rather than half as much over here. Okay, so the other thing that can cause pass-through to change is the elasticity of supply, as we talked about before. If we have increasing marginal cost, so supply is somewhat inelastic, that's going to mitigate the price increase. On the other hand, if we have decreasing marginal cost, which you could have under a monopoly, right? In fact, you'd almost always have that under natural monopoly, then a small increase in marginal cost leads to a bigger increase in price, because you walk up the demand curve, up the cost curve, to a point where the costs are actually higher when you decrease your quantities. Okay. So to wrap up, and we'll wrap up early today, let's go back to a few of the applications of the incidence logic. So we talked before about the optimal taxation of international trade. And Russell, how does that work out here? How can we use incidence logic to think about the optimal way to tax international trade if the foreign firm is, say, a monopolist?
That's a good question. So if you're the domestic government,
yeah,
it's a foreign firm, it's a monopolist.
Yeah.
I guess maybe think about subsidizing some domestic industries of that trade, so you can introduce some competitive quantity.
Well, imagine you're just taxing the imports of the good.
Just taxing.
What would be the optimal thing to do? And how does that relate to pass-through? Well, you don't care about the harm on the foreign firm, right?
Right, that's right.
You only care about your domestic people's harm, right?
Yes, I guess you tax in a way that they pass as little on as possible to the.
Well, if you could, but I mean, even if we just have a standard tax, right? The government is going to gain directly a tax revenue that's equal to D, right? But the domestic consumers are going to lose the pass-through of that, plus T times D prime, right? So the government optimal tax is going to have exactly the same formula that we had before in the perfectly competitive case if we express it in terms of pass-through rates, right? But if we express it in terms of 1 over the elasticity of supply, which is how it was before, that's not going to generalize, right? So expressing it in terms of pass-through rates gives you the exact same formula before and lets you unify these two things, which is sort of one nice thing about it. And one thing it shows is that if the pass-through rate is greater than 1, which can happen under monopoly, right? In fact, we saw that right here. If you had a constant elasticity demand, the pass-through is always greater than 1. Then you're never going to want to tax imports. You would actually want to subsidize imports. So that's an interesting implication that comes out of monopolistic competition, which is usually using the CES demand to model it, right? Because CES always has pass-through greater than 1, you never want to tax, you don't even want to subsidize imports if the foreigner is owed, right? Okay. Second, okay, so let's talk about creating a new market. So imagine that we're going to give a concession to some firm to be a monopoly over some market. Vidur, could you tell us a little bit about how the pass-through logic would be relevant to like how we'd want to allocate that?
It would be like the meters in Chicago.
Uh-huh.
You'd have them pay some amount of money to the government in order to gain the.
But how would the pass-through, imagine that we had different people we could allocate it to, and the pass-through of their demands would be different. How would we want to allocate the good?
You would want to allocate it to the lowest pass-through so that it affects the consumers the least.
The lowest pass-through, really?
Or is that the highest pass-through?
Well, we want the consumers to gain the maximum amount of surplus, right?
Yeah.
And we know that the ratio of consumer surplus to producer surplus is pass-through.
So then you would want the highest pass-through.
So you'd want the highest pass-through one, but also the one that bids the most money, because obviously those things are related. So you'd actually want to handicap the auction in favor of whatever firm has the greatest pass-through, if possible, right? Before we had that the ratio was 1 over 1 minus the, now the social gain associated with having the firm come in is 1, which is the firm's profits, plus the pass-through rate times the firm's profits, compared to 1, which is how much the firm is going multiplied by their profits, which is how much the firm is going to be willing to bid. And so you'd want to handicap all the firms proportional to the pass-through rate. Before, the social gain was equal to producer surplus multiplied by 1 over 1 minus the pass-through rate, because that was the fraction that was captured by the firm. So in both cases, you want to handicap in terms of firms that have a high pass-through rate, because the higher the pass-through rate, the more of the benefits of that firm coming in that the consumers will capture relative to the firm, right? So you'd like to favor projects, subsidize projects with niche markets or with high-income consumers, because those are going to be ones where the pass-through rate is going to be greater, right? So this is basically the same logic as before. It's just that the pass-through rate enters in a different place, right? So what I wanted to sort of emphasize is that much of the policy interventions we want to take under market power relative to what we'd want to do under perfect competition can be summarized by just thinking about the ways in which it changes the logic of incidence and pass-through. So these are two examples that are not obviously related to just a standard tax incidence problem, but we can think about how things change with market power just by thinking about how incidence and pass-through rates change under monopoly versus competition. And we're out early. I've kept you late many times. So go study or whatever else you want to do. Thanks.